Hello friends, welcome to my channel. Let's have a look at problem 152, maximum product subarray. In this video, we're going to give a treatment based on dynamic programming, or we can see we do linear scan and check. First, let's look at the statement of the problem. Given an integer array called nums, find a contiguous non-empty subarray with the array that has the largest product, and return the product. So notice that the return is the product, not the array. So the test cases are generated so that the answer will fit in a 32-bit integer, and a subarray is a contiguous subsequence of the array. So with that said, let's look at the two examples. So in example 2, the things are special because all the elements are non-positive. So here we have a 0, so the output is 0, largest possible. And in example 1, so the output is 6, which is 2 times 3. So if we include 2 in the product or in the subarray, so this will result in negative number for sure. We cannot include negative 2, right? So that's the point here. So notice that this length of the nums list can be up to 2 times 10 to the power 4. It's a large number. And the element in nums list is bounded below by negative 10 and bounded above by positive 10. Here, the important thing to be noticed is that the elements can be negative. So the last one is some consistency assumption. So with that said, actually we can look at our treatment. So here we're going to use, if we want to see the method is dp, or we can see we just need to do linear scan and check during the process. So idea is the following. So for each index I, we could find the largest product ending at I. Then we just need to update for the maximal product for all these ending indices. So here the update is also very intuitive or straightforward. Assume little m and capital M are the smallest and largest products ending at index I-1 respectively. And then at index I, we consider 3 possible products. First is little m times nums I, and the second is capital M times nums I, and the third one is nums I itself. Why we consider nums I? The reason is that we want to find contiguous non-empty subarray, right? So because this non-empty assumption, we need to consider nums I. But why we should consider this little m times nums I and big M times nums I? The reason is that nums I can be negative. If all the elements are positive, we just need to consider the maximum number times nums I, right? But if nums I is negative, then we actually make the previous largest value to be the smallest now. So then at index I, so the little m will be the min of the above 3, and the capital M will be the max of the above 3. So this sentence explains again why we consider the 3 possibilities above. So as this problem is very straightforward, so we are going to omit the walkthrough of examples and directly do the coding part. So for the coding part, first I'm going to do some initializations. So first I'm going to initialize a variable called result. So this is going to store the largest possible product, and also at the beginning, so we're going to set the little m and the capital M. So for this 3, I'm going to set all of them to be nums 0, and nums 0, right? So this way, actually, we finished our initialization. Also, we can make some preparation. Let's say we get the length of this nums array, right? So next, we are going to do the for loop. So here, I want to make a comment. The elements in the nums list can be 0. And these 3 possibilities covers that case, right? So if a number is 0, so these things are going to be 0. But we want to During the for loop, we are going to compare the maximal product ending at each index. Then the largest of these things will be the final result. So this is the first step. Now let's look at the second step. So the for loop, so all the update, DP update, if we interpret it as a DP, right? So then for I in range, so we are going to start from 1 and ending at n-1. Then we're going to consider 3 possibilities, right? So it's little m times nums I, and capital M times nums I, and nums I itself. So we put it in a temporary list so that we can easily get this little m and capital M at the current state, that is min of temp and max of temp. So once this is done, so we can actually compare the result state. We are going to find the maximum. The result is the previous state and the current capital M, right? So this is the second step. Actually, the second step contains the main problem logic. The third step is nothing but return. So we're going to return the result variable. So here we initialized a running variable result to update the maximum product at each index. So another choice is that so we can use a DP table and get the little m and capital M at each of the indices. Then we take the maximum operation. So anyway, the effects are the same. So with that said, the effects are the same. With that said, let's do a check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for this specific problem. So it's also the end for this video. Thank you.